CNT120, Chapter 1. We're on the section on networking hardware. Now, some of these we've mentioned as we've gone along already, but we'll touch on each one individually. One of the first ones we mentioned earlier the hub and the switch, but let's talk about the switch a little bit more detail. Our networks today, Ethernet networks today, are using switches. We're not using hubs anymore. The switch is going to receive the data coming in its port, read that, and then make a decision where it needs to go and try to pass it out a single port. It's going to try to pass out a single port. If it doesn't know, it will pass it out multiple ports to try to say, hey, does anybody know where this goes? But once it learns that a computer is on that port, it puts that in a little table. It actually reads the MAC address and tries to keep that in a table. And so the next piece of data comes in, it goes, let me see if I have that anywhere. Oh, I have that on this port, and it only passes it out that port. So my layer 2 switches, which many of them are going to read MAC addresses and send the device out a port to that MAC address. Switches can also be layer 3. That's a special type of switch, a layer 3 switch. In that case, it's going to read IP addresses and try to send to that IP or that network. Now, some of these might be a little bit foreign to you. Just kind of keep them in the back of your brain for now. We're going to talk about addressing in Chapter 3. So just kind of keep that in the back of your brain for now if these things are sounding a little foreign. But there are layer 2 and layer 3 switches out there. Layer 2 are going to read MAC addresses. Layer 3 have a little bit more intelligence. They're going to read IP addresses and try to move data to that particular IP. All right, so here, this is another diagram showing you that concept before of when data comes in, it tries to read it and send it out only a particular port. And what that allows the switch to do is literally have 2 or 3 or 4 conversations going on simultaneously, which adds to the overall throughput with a switched network. Here's an example of a couple switches. They're as small as you can get a 4-port switch, 12-port, 24, 48, and then up to a chassis grade switch. This is the kind of switch that would be in a main closet on like on one of our college campus buildings, or in a hospital, the data closet on the floor of a hospital, multiple cards of ports, multiple power supplies, and sometimes this is like the brain of the switch. Sometimes there's more than one of those for redundancy purposes. That can all be engineered into the switch for redundancy and some reliability. Next device is our network card, network interface card. Our network interface card, or NIC, sometimes you hear them called a network adapter as well. This is a network port used to attach the device to a network. Most of our devices now have a network port already installed. Once upon a time, if you had a computer, you had to actually go out and buy a network card and install it into it because it didn't come with it. Well, computers now come with usually 2 types of network cards, one for a wired connection and one for a wireless connection. That's pretty common. So here, this device is literally a transceiver. It's designed to transmit as well as receive data. That's the TX and RX, transmit and receive. It's designed to transmit and receive data. This has capability for physical as well as data link layer functions, which we'll talk about in a little bit. Physical is the cable connection, that layer 1 connection, and the data link is my moving data on and off a wired network or moving data on and off a wireless network. And that's where we have down here, I put a little heads up of CSMA-CD for wired network, CSMA-CA plus acknowledgement for wireless network. Again, planting the seeds for things we're going to talk about later, so don't panic too much there. So here is a bunch of network cards. I have a whole bunch of pictures here to show you. Here's a bunch of different type of network cards. Well, let's break some of these out a little bit. Actually, these were wired ones right here. These are a bunch of different wired connections, coax, twisted pair, fiber optic, etc. Here's some wireless ones, USB wireless, wireless with an antenna on the back, wireless with an external antenna. Here's one from a printer. Here's one on an IP phone. Okay. Here's one integrated onto the motherboard of my desktop. That is common now. Once upon a time that was special. Now that's common. All right. Back in time, you might have had, there might not have been a network card in your computer, and you might need to snap one in. So you would have had to open the case and look for what kind of slot, what type of expansion slot you had on your computer to be able to snap a network card in. Super, super, super old network slot is ISA. PCI was probably common for a lot of people. That's what those two are there. PCI Express is probably what's in most computers now. Okay, those other two are pretty old by this standard now. This is PCI Express versus PCI. Here are some USB ports in the back of the computer that you could attach a little wireless dongle, if you will, in there to give you a wireless network access if your computer didn't have it. Older laptops had PCMCIA slots. This is one of my first wireless cards I slid into a computer. I thought it was pretty special. I had a PCMCIA slot wireless card that slid into my laptop. Here's a close-up of the really old ISA slot for a network card. You notice that's a coax connection right there for a coax bus. Here's PCI. Here's a wired Ethernet PCI slot, and then here's a wireless that we're going into a PCI slot. And then here's PCI Express. Here's a wired NIC with PCI Express, and then here's a wireless NIC with PCI Express. Just getting you to see some of these up close. And there's your USB. Quite a few different devices, laptops and things, I've used a USB to wired connection or USB to wireless connection, just for ease of connection on my device. A couple laptops I had these, and here's a wired PCMCIA. Here's a wireless PCMCIA wireless card. Okay, so network cards, lots of different variations for connecting to a network. Most today are going to be integrated here, integrated into the motherboard that I can literally just plug in and go. That's what most things are today. All right, other network device is our router. Okay. Routers are designed to literally connect networks together. It's designed to manage traffic between networks. It's also managed to connect two different networks together. That's what they're designed for. Whether it be my homeowner router or my industrial grade router, they're going to serve that same basic function. Connect these networks together and move traffic between them. My homeowner router is connecting between my Ethernet LAN in my house to the network that my provider is giving me. Whatever my provider is, whoever that provider network is and what they're doing, that router is going to connect their network and their technology to my network Ethernet LAN technology. The same is the case for your industrial grade or commercial grade router. Same type of function. Connect my LAN and my devices in my network to the provider network. And there's my homeowner, going to this, whatever this is, going to my ISP. So my router is going to connect my network to whatever this technology is that's being used. And there's my network in a box that we talked about before. That's what's really in my I'm putting low air quotes, my wireless router at home. That's what's really in it. All those pieces of equipment are in there. The network, the router itself is designed to connect maybe two Ethernet networks together or two different networks together, LAN to WAN. It's usually going to be the LAN to WAN, my LAN to whatever the WAN provider is. It directs traffic between them. It's designed to get data to the correct network. The router only really cares about getting to the correct network. The switch is designed or worried about getting to the correct device. So think about this concept for a second. Data comes from the internet into the hack network. I'm using little air quotes here, the hack network. Well, the first router it hits, that first hack router, its job is to say, okay, do you want to go to York, Lancaster, Lebanon, Harrisburg, Gettysburg? Which one do you want to go to? So the router's going to read that addressing and get it to York as opposed to Lancaster. And once it gets to the York network, the router's like, I'm done with y'all. The switch now reads it and goes, what computer do you want to go to? And the switch is going to try to get it to the correct computer. So my router is really only concerned with getting to the correct network. The switch will get it to the right device. My router is going to operate at layer 3. It's going to read that IP addressing, more than likely, and get it to the correct network. Again, York as opposed to Gettysburg, Harrisburg as opposed to Lancaster kind of thing. It is going to be slower because it needs to read more information and process more information. The router is going to take a little bit more time to make its decision and get it to the correct network. So it's going to add a little latency. That's the trade-off for the intelligence you're getting. It's going to maintain a table of all these networks and how to get there. That's its routing table. It's going to maintain a routing table, and that is a table of all these networks and how to get to them. That's what it's going to maintain. If I were to crack open a commercial grade router, this is what I find inside. It's basically a specialized computer. It doesn't have the monitor, keyboard, and mouse ports and everything on, but it has all the other things that you're used to seeing. Here's my homeowner router. Here's a couple examples of homeowner routers from the back. Okay. And then here's my commercial router with some LAN ports as well as some WAN ports. Okay. They're all serving that function of getting it to the correct network. All right, we'll come back to the next part and start talking about OSI model.